Have you ever wondered how the speed of an object changes over time? Or why a ball thrown into the air slows down at the peak of its arc, then speeds up again as it falls? These are all questions that can be answered by understanding the concepts of acceleration and the equations of motion. Acceleration, simply put, is the rate at which an object's velocity changes. Think of a car that's just started moving from a traffic light. As the car speeds up, its velocity is increasing, and this change in velocity over time is what we call acceleration. But what if the car slows down? That's also acceleration, but in the reverse direction, often referred to as deceleration. But what about a snapshot of an object's velocity at a specific moment? That's what we call instantaneous acceleration. Like a camera capturing a moment in time, instantaneous acceleration measures how fast an object is accelerating at a particular instant. For example, the velocity of a ball thrown into the air changes continuously due to gravity's pull. We can calculate the ball's instantaneous acceleration at any point during its flight. So how do we make sense of all this motion? That's where the equations of motion come in. These mathematical relationships help us understand how an object's motion changes under the influence of forces. The first equation of motion connects velocity, acceleration, and time. It tells us that an object's final velocity equals its initial velocity plus the product of acceleration and time. The second equation of motion relates displacement, how far the object has moved, to velocity, acceleration, and time. It gives us the object's displacement at any time, considering its initial position, initial velocity, acceleration, and the time elapsed. The third equation of motion ties together velocity, displacement, and acceleration. It tells us that the object's final velocity squared equals its initial velocity squared plus twice the product of acceleration and the change in displacement. In the world around us, acceleration is everywhere. It's in the car speeding up from a standstill, the ball rolling down a hill, the skydiver plummeting towards the earth, and even the rocket shooting into space. In conclusion, acceleration, instantaneous acceleration, and the equations of motion are fundamental to understanding the motion of objects. These concepts, deeply rooted in physics, help us decode the mysteries of motion and the effects of forces, finding applications in diverse fields like engineering, transportation, and sports science. Remember, every time you see an object moving, there's a fascinating story of physics behind it.